Hey guys, welcome back to my channel. In this video, we're going to be learning about various different ways to factor special trinomials. Let's get started. So the first thing that we're going to start off with is factoring trinomials when you have two variables. So when you have something like x squared plus 9xy plus 14y squared. So as you can see, we do have two variables here. We have x right here and we have y right here. So because we have these two different variables, we have a different way of doing things, although it's really not that different. The way you would solve this is basically just solving this like a regular trinomial. So you'd factor it out like it was a regular trinomial, and you'd kind of just add the y on afterwards. So let's try doing an example. So we have x squared plus 9xy plus 14y. So instead of looking at this as x squared plus 9xy plus 14y squared, let's look at this as x squared plus 9x plus 14 and just factor it like that. So x squared plus 9x plus 14. So how would we go about factoring this? Well, we have our x squared plus 14. So we look at our signs and both of them are pluses. So we know that it's going to be in a form like this. Both of these are going to be pluses. These are going to have numbers right here. So the two numbers right here, looking at our 14, we know that they have to multiply up to 14 and add up to 9. So if you go through the list of factors for 14 in your head, the one that adds up to 9 and multiplies to 14 is 2 and 7. So you would write your 2 here and your 7 here. And so x squared plus 9x plus 14 factored would be x plus 2 times x plus 7. So how does this have anything to do with that? Basically, what you have to do here is just add your y on to the very end of each factor. So this factor would be x plus 2y times x plus 7y. So that would be our final factored answer. It's pretty easy, and if you multiply it out, you're going to see that we get the exact same thing as our original equation. So let's try multiplying this out. X times x gives us x squared. X times 7y gives us 7xy. 2y times x gives us 2xy. And 2y times 7y gives us plus 14y squared. And if you simplify this, you're going to get x squared plus 9xy plus 14y squared. And that is the same thing as this. So pretty simple. All you do is factor as if it's a normal polynomial and tag the y on at the end. So let's do a few more of these. Let's say we have x squared minus 5xy minus 6y squared. This is what we want to factor. So to factor this, remember, we just factor it as if it's a normal polynomial, so just ignore the y for now. So if we are ignoring the y for now, we would have x squared minus 5x minus 6. And so looking at our signs, they're both negatives, which tells us one of our factors is going to be negative and another one of our factors is going to be positive. So let's go ahead and factor. So our factors have to multiply up to -6 and add up to -5. So one of the factors that could add up, that could multiply to -6 and add up to -5 would be -6 and 1. So we could put 6 here and 1 here. And we can multiply it out just to make sure, because the negative ones are sometimes tricky. So we would have x squared plus x minus 6x minus 6, which simplifies to x squared minus 5x minus 6. Okay, so we're good. These are our two factors. So now from here, Remember, all we have to do is take this and put it here, so that would be x minus 6, and we have x plus 1, and you would just tag the y on to the very end, and that should be your answer. So we can multiply it out one more time to see what we get. So we have x squared plus xy minus 6xy plus 6y squared. So simplifying that, we have x squared minus 5xy plus 6y squared. Sorry, my bad. Minus 6y squared. That is a minus. Minus 6y squared. So those two are the same, which means that this is our final answer. Let's try one last one. So for this one, let's say we have 2x squared plus 14xy plus 24y squared. Okay, so for this one, we're going to do the same thing. You guys can pause the video and see if you can do this one on your own. So for this one, remember, our first step is to just ignore our y value. So we would have 2x squared plus 14x plus 24. From here, we factor this like we normally would. The first thing I notice here is that the x squared has a 2 in front of it, and all of the other terms are also divisible by 2. So I'm going to go ahead and factor out that 2. So now we're left with 2 times x squared plus 7x plus 12. So now you factor out x squared plus 7x plus 12 as normal, and because both of the signs are positive, we know it's going to be in a form that looks somewhat like this, with both addition symbols here. From here, we look at our c value, or the 12, and we know that our factors have to multiply to 12 and add up to 7. So the factors of 12 that multiply to 12 and add up to 7 are 3 and 4. And since these are pluses, I can really just put them anywhere. It shouldn't really matter. So x plus 3 and x plus 4 are our factors. So this should be equal to that. So now we come and we take this and put it up here. So we're going to have 2 times x plus 3. And then remember, you just add on the y to get from here to here. So you tag on the y to the first factor, you tag on the y to the second factor. And this should be your final answer. So we can multiply this out just to make sure we got it right. So we have 2 times, and then we're going to multiply out our polynomials first. So we have x squared plus 4xy plus 3xy plus 12y squared. So that's the same thing as 2 times x squared plus 7xy plus 12y squared. And if you distribute that 2 out, we're going to get 2x squared plus 14xy plus 24y squared. That is equal to that. And so 2 times x plus 3y times x plus 4y is our final answer. So now that we know how to factor trinomials that have 2 variables in it, let's move on to our next topic. So our next topic is factoring perfect square trinomials. So a perfect square trinomials is basically like if you have something like this. So 9x squared plus 12x plus 4. So over here you can see that our first term, 9x squared, and our last term, 4, both of them are perfect squares. 9x, the square root of 9x squared is just 3x, and the square root of 4 is 2. So because our first term and our last term are both perfect squares, it becomes increasingly easy to factor this because your final answer is just the square root of your first term, which is 3x, plus the square root of your last term, which is 2, and you put parentheses around it and you square the entire thing. And that is your answer. So we can expand this to see if we get the same thing. So 3x plus 2 squared is the same thing as 3x plus 2 times 3x plus 2. And if we expand this even further, we get 3x times 3x gives us 9x squared. 3x times 2 gives us plus 6x. And then 2 times 3x gives us plus 6x. And then 2 times 2 gives us 4. And when we factor this, we get 9x squared plus 12x plus 4. And that is the same thing as this. So 3x plus 2 squared is our final answer. So let's try another one. Let's say we have n squared minus 14n plus 49. So this is also a perfect square trinomial because the square root of n squared would just give us just n, and the square root of 49 gives us just 7. But one very important thing that we have to take note of here is that negative right there. So in our previous one, both of them were positive, which meant that our plus sign in the middle would be positive. But since we have a negative here, that means instead of being n plus 7 squared, it's going to be n minus 7 squared. So we can check this by, again, expanding. So n minus 7 squared is the same thing as n minus 7 times n minus 7. And expanding that further gives us n squared minus 7n minus 7n plus 49. And simplifying this gives us n squared minus 14n plus 49. So this is the same as our original equation, which means that n minus 7 squared is our final answer. So let's say we have 9a squared plus 30ab plus 25b squared. So as you can see here, we have a perfect square trinomial, except this time it has two variables. So like in our last one, we could factor this out as if it was a normal trinomial. So that would be like, we would factor it as it was like na squared plus 30a plus 25, right? And then, so even if we had this, so let's say we had this, we could have, this would still be a perfect square trinomial. We still have our first term as a perfect square and our second term as a perfect square. So that would give us 3a plus 5 squared. But since we have these two b terms here, we would add the b at the end. And so that would give us 3a plus 5b squared. So we could go about it that way. But even though this has two variables, we don't have to do it that way. Instead, we could go ahead and just treat this like a normal perfect square trinomial instead of ignoring the b first. So we have 9a squared, whose square root is 3a, and we have 25b squared, whose square root is 5b. And so, since both of these were perfect squares, we could just add these together, 3a plus 5b, since both of the signs are pluses, and put a square after them. And that should give us the same answer. So I could factor this out. So 3a plus 5b squared is the same thing as 3a plus 5b times 3a plus 5b, which is going to give us 9a squared plus 15ab plus 15ab plus 25b, which is b squared, my bad, which is the same thing as 9a squared plus 30ab plus 25b squared. So since this is the same as our original equation, 3a plus 5b squared is our final answer. Now that we know how to factor perfect square trinomials, let's move on to another type of problem. So let's say we have an equation that's something like this. Y squared minus 16. So this is what's going to be called a difference of squares. So this is a difference of squares because both of these terms, because first of all, it only has two terms. Second of all, it's being subtracted. And third of all, the most important one is that both of these are perfect squares. So the differences of squares rule basically says that if you have something like a squared minus b squared, that is the same thing as a plus b times a minus b. So in this instance, our a squared is y squared, and our b squared is our 16. So what you would do here is we have our equation in this form, but we want to get it into this form. So what we would do here is square root both terms. So the square root of y squared would be just y, and the square root of 16 would be 4. And so with this, you have your a value and your b value. So our a value is y and our b value is 4. So from here it says a plus b times a minus b should be equal to a squared minus b squared. So our a is y and our b is 4. So we would have y plus 4 times y minus 4. And that should be our final answer. So let's see if we expand this out if we get y squared minus 16 to check if our work is correct. So expanding this, we get y squared minus 4y plus 4y minus 16. And expanding this further, we get y squared, and then our minus 4y and our plus 4y cancel out and make each other 0. So we wouldn't add anything there, and we would be left with minus 16. So we do get y squared minus 16. So our final answer is y plus 4 times y minus 4. Let's try one last problem. Say we have 25m squared minus 36. So we would first square root both of our items. So the square root of 25m squared would be just 5m, and the square root of 36 is 6. And so our a value is equal to 5m and our b value is equal to 6. So remember, difference in squares is a plus b times a minus b. So that would be 5m plus 6 times 5m minus 6. And that should be our answer. So let's check our work. So by FOILing this out. So 5m times 5m gives us 25m squared. Then 5m minus 6 gives us minus 30m. 6 times 5m gives us plus 30m. And 6 times negative 6 gives us minus 36. Simplifying this, we get 25m squared. Minus 30m plus 30m gives us just 0. So those cancel out. We are left with minus 36 here. So this is the same as our original equation, which tells us that 5m plus 6 times 5m minus 6 is correct. So that's it for today, guys. I hope everything was clear and easy to understand. If you like my videos, please like and subscribe. Also be sure to drop any questions you have in the comment section below. Thank you so much for watching. See you next time. Bye!